Okay, any questions before we begin? Nope, okay, cool. How many people here know me before you saw the meetup? Know of me? Couple people, okay. Just so everybody knows, basically, I've been doing technology since 1996. Started off in the US Army, doing electronic repair, got my MCSE back in 2000 with NT4. Was in corporate world for a while, had my own, became a consultant, had my own company with 9 employees. And then basically in 2009, when the Great Recession happened, I zigged when I should have zagged. Basically I had to close down my business, and I went to a master's degree program. And while I was in the master's degree program, I realized I didn't give a damn about anything that I was learning. Like literally all the material I was learning, I would not have paid my employees 25 more cents an hour to understand any of it. So I had this idea in 2009, what if there was like on-demand like video education where people could just click and learn about the things that we get paid for. So I started doing tech education back in 2009. Basically built my own infrastructure back then because you couldn't say like YouTube. Nobody knew what YouTube was. One thing led to another. I wound up on YouTube. I've now got like 1 million subscribers on YouTube. Basically my idea now is in 2025, this actually came back from 2020, is what I've been finding is in 2009, we had a lot of professionals and getting access to good information was very difficult. Like I had to learn voice over IP literally from Cisco white papers. And there's nothing that sucks more than trying to learn the technology from actual white papers. And so that was the thing. In 2009, just having a guy sit here and talk to you about voice over IP was a good thing. What I'm finding now, as I've talked to a lot of my viewers over time, is people have more and more access to education, but they have less and less access to human beings. They know more about the technology and know less about what it is that we actually do and have no community. So they get the certifications, they get the degrees, and I've had so many conversations with people literally coming out with 4-year degrees, not knowing what the hell to do next. And so part of basically the idea with Silicon Dojo is what if I bring some of the ideas from the YouTube world into the physical world where basically people can just come, you can learn, you also, become a little cohort, you meet each other, you see what everybody else is doing, and basically that type of thing. Both you get the education and you get the whole in-person experience is basically the idea. One of the big things, I know everybody right now is scared of AI. It's weird, I've been doing tech for 30 years. I've seen all kinds of maladaptive behaviors out of geeks. We are not the sanest human beings in the world, and that's why we do what we do. I have seen arrogance and ego and sad and all kinds of different things. I have not seen this level of depression ever in my life. Even in the IT world, again, for a lot of people that don't realize it, if you go back to 2010, 2012, there's these things called orchestration tools that allow you to automate a lot of things in the IT world. I was at the Interop conference in 2012, and the keynote speaker literally said that they had doubled the headcount of their employees at the exact same time they had decreased their tech staff by 1/4. And even in that time period, geeks were not that depressed. They were like, okay, we'll figure out what to do next. With the whole AI thing coming about, so many technology professionals I talk to are just flat out depressed. There's this idea that our profession is over, AI is going to do everything, and we should go off and be painters or whatever else. One of the things I'll tell you is AI is a stack, AI is a stack more or less like any other stack. And so if you learn to build for stacks, then at the end of the day, you're gonna be fine, right? I did a fireside chat with this guy, Du, who does, he's the founder of a startup company called Contextual AI. They have $100 million in funding, literally for creating something called RAG 2.0. All RAG 2.0 is a database type system that AI system can use basically for like a memory subsystem. They've gotten $100 million basically just to create a better database system. And so that's one component of artificial intelligence. And so if you look at AI as a tech stack, you're gonna be a hell of a lot more comfortable with this stuff if you just think, it's some kind of magical thing that's gonna take all of our jobs away. So anyways, that is the opening thing. If you don't know, so let me see here, just so you know, the main site for us is Silicon Dojo, silicondojo.com. So this will show upcoming events. You can become a member here, so you can get email blasts and that type of thing. We have the fireside chats that we've done so far. I do these on Zoom if you're interested in watching those. And we also have self-study programs, so any of the stuff you want to understand more of. This is a 48-part, no, not that. Anyways, where's Python? Python. Python is a 48-part Python series. This is an introduction to programming series. This is SQLite, so it's a relational database system that's very easy to use. And then the Bottle web app framework is a web app framework we generally use in classes. So these are just self-study classes. You can come here, you can watch them at your own leisure and that type of thing. So that's all on here. These classes are free to the end user. The idea is, hey, what if we, come on, work this time. There we go. Hey, what if we get funded basically through crowdfunding? So I go onto YouTube and I scream about really stupid shit. If you watch me on YouTube, believe me, it is stupid crap that I scream about. But anyways, I get paid for doing that. So that helps fund this. And also when people throw money into the donor box account, that's what helps fund this. And the idea is, what if the people who can and are willing to pay, and then everybody can just come and learn. That's the basic idea. And yeah, that's about it. Any questions on Silicon Dojo in general? Nope? Okay. So we are going to be starting to do this class on the introduction to OpenAI's API today. So that is loud. Anyways, so the last class we did was on the Ollama framework. So the Ollama framework allows you to run LLM models directly on your local computer. So basically you download Ollama, what you do what's called pull an LLM model into your computer, and then you can interact with it directly. So you can interact through it with through the command line, you can interact with it through Python, and then you can basically build on that in order to create web applications. The thing is, if you use Ollama, are you here for OpenAI? Come on in. Did you have any problems coming in? No? Okay. Traffic. I can't do anything about traffic. Let's see here. So the thing is, if you're running Ollama, people really like to use Ollama because it is on their local computer, and for some reason they feel like that's better, which is fine. With Ollama, depending on the size of the model, you can actually run it on a Raspberry Pi. There are very small models out there, but the issue is the quality of the models might not necessarily be that great, and when you start using larger models, you need more hardware. And so one of the questions that you run into is, do you want to pay $5,000 for one price for a server that you can use forever, or do you want to pay a fraction of a cent every time you do a request to a service like OpenAI and have that build up over time? So there's reasons to use models on something like Ollama, AI with Ollama, but you can use what's called an API interface to actually connect with OpenAI. So when we talk about OpenAI, this is not ChatGPT, the API. So OpenAI has many different services. ChatGPT is the interface you go into, you make the request, you ask it to make a picture or whatever else, and it gives that to you. The API service, basically all this is with your code, you're able to connect into their back-end LLM services, and it provides a response for you. Now the important thing, because we ran into this in the last class, is people kept saying things like, well, it remembers, or it does this, or it does that. It's important to understand when you're dealing with the LLM is one singular component. It's one singular resource in an overall system that you're going to be building. So with OpenAI's API or with Ollama, if you do not build memory, memory does not exist. Basically with this system, what happens is you make a request, it gives a response back, and that's it. If you wanted to have memory, if you wanted to have all kinds of other things, you actually have to build all that in. And that's going to be things we're going to go to in other classes. So let's see here. We'll go through. In order to do this, in order to use OpenAI's API, basically you can use any computer that runs Python 3. So Windows, Mac, Linux should be fine. I will tell you Ubuntu is the right answer. If you want to be doing AI projects, Ubuntu is the right answer. It just makes it easier. More people are showing up. Yay! When you are doing the API, oh, yeah, even more people. 6 o'clock people. Okay, anyways, come on in. If I was giving grades, I'd fail you all, but sadly I am not giving anybody any grades. Anyways, okay, here is that for you. Here's this for you. More paperwork. Everybody loves their paperwork. All right. So the cool part with using an API is that you're actually sending a request to an entirely different system. So it does not matter what GPU you have on your computer. It does not matter what CPU you have on your computer. It barely matters what RAM you have on your computer. As long as your computer functions, it will be fine. And that is one of the values of using an API over OLLAMA. So in OLLAMA, when you're using a local LLM, everything has to run locally. So you're restricted by the resources your local computer has. By sending out the request to an API, you can literally use, there's something called a Raspberry Pi Zero. You could have a Raspberry Pi Zero running very complicated artificial intelligence routines because it's basically outsourcing all the processing work onto OpenAI's servers. So that's the good thing about this. So you don't need NVIDIA GPU, you don't need a high-end GPU. You can basically use a potato, as they say. When you're going to create an account, so in order to do these projects at home, you are going to need to create an account. This is not a ChatGPT account. So there's a ChatGPT account that costs you $20 a month, and then there's the OpenAI account. Come on in. There you go. There's the OpenAI account. So you're going to have to create an OpenAI account. And in this, you're going to have to plug in your credit card. So be very, very careful about this. Very, very careful about this. So when you pay for ChatGPT, you pay $20 a month. No matter how stupid you are, it's only ever going to cost you $20 a month. Here's the thing. When you start doing these API calls, every single time you do an API call, that's going to burn what are called tokens. Tokens, depending on exactly what you're going to do, are going to cost you a fraction of a cent. I make this joke about a while true loop. A while true loop is a loop that continuously goes and never ends. It will literally process as fast as your computer will process it. So if you do something stupid and you start just pinging the hell out of this API, you could get a very large bill. So one of the things I'm going to show you in a few minutes is how to limit that. You can put a budget, so you can put an organizational budget for an entire month. So today I've just put it for $30 so people can actually use this. And you can put a project budget. So if you are doing, let's say you're using this in the enterprise, you can put a budget of a couple $100, and then you can create a lab project and give that lab $5. So if you screw up and do a while true loop, you burn through $5 and not $300. So be careful about that. One of the things that's really screwed up with this too is, so you can put money in. So they used to charge you after you spent the tokens. Now they charge you before you spend the tokens. They now allow you to auto refill your account too, which is a nice little trick. So you can put in $50 and you say, all I'm going to be charged is $50. Unless you check the little box so that it doesn't auto recharge, and so it'll just keep burning up money. So do be very careful with that. In order to write the code today, so our IDE, Integrated Development Environment, is always going to be VS Code. As I tell everybody, if you are smart enough to not use VS Code, use whatever the hell you want, but it'll be harder for me to troubleshoot. Install the Python extensions, because we use Python. We use Python 3 to interact with OpenAI, so you should have that installed on your computer. In order to use Python with OpenAI, you need the OpenAI module. So you can install that, Python 3-m pip install OpenAI. And then I'm going to show you something with environment variables, where basically you just have to install this module, python-.env, will allow you to do environment variables. We'll show you that in a second. Any questions up until this point? Yes?
Is it okay if I use Anthropic's API instead?
You can use whatever you don't want troubleshooting help with. The thing is, like I say, when I actually got quite a few people here. You got like 30 people. I'm trying to help people out. Like simply knowing color, like if I walk up and I know color codes, I can go, I know what you did wrong. If everybody's using different IDEs, it's like, that's a squiggle. So whatever you want to use. Okay, so let's be thinking about LLM architecture. This is one of the big issues that we have right now with a lot of folks that are scared of AI. They're like, AI is going to take my job. And there's a good chance it's going to take your job, let's be honest with you. Your job is probably going to go away. And the question is your career going to go away? And the thing is, what I try to explain to all new people is this, my friends. This is what we get paid for. We do not get paid for functions. We do not get paid for API calls. We do not get paid even really for the specific stack that we're using. We get paid to draw really fancy diagrams on whiteboards and try to figure out what the hell it is that we're talking about. And once we draw these very fancy diagrams on whiteboards, we then turn that into a system. True story, everybody should know this story, is that apparently nobody should be working in the tech world in the United States right now because all the jobs were taken by Indians. So again, I'm 49 years old. I remember 2000, I remember Y2K, and we were all very specifically told the world is flat. All tech jobs are going to go to India. If there's a fiber line that runs from the United States to India, why the hell are you going to pay a coder in the United States $150,000 a year when you can pay somebody in India, $50 a year for the exact same work? What they figured out in the real world is that the code didn't really matter. Your $150,000, $200,000 salary actually was peanuts if you didn't have the right communication. The real value is in project management, design, planning. The rest of it, your salaries are whatever. They're rounding errors, essentially. And so one of the big things you do need to understand in the tech world is if you understand how this works, you're going to be fine. If you think your job is a JavaScript stack, the stack will go away. And so that's when we're talking about things like the LLM architecture. You need to be thinking about how you're going to be building your AI system. So again, in the last class, I was talking about Ollama. And people really like Ollama, right? Ollama is local. If I'm going to build a system, I'm going to build a local system. I'm not going to put that crap on the cloud. I don't trust the cloud. Or other people are like, well, I don't want to deal with a server, so I'm going to put my stuff on the cloud. Here's the deal. When you're actually building stuff in the technology world, I don't give a crap. I have worked on 20 different stacks at this point in time. Basically, the questions that you need to ask yourself is what problems do you need to solve, right? What resources does the company already have? Institutional knowledge, legacy systems, maintenance agreements, those types of things. How much money are they going to give you? What regulations and requirements they're under, all of that kind of stuff. And then based off of that, you figure out basically how you're going to be building your architecture, right? Your architecture should be based off of the requirements of your client and the resources that they have to offer, right? If you give me $10, I'll build you something. It'll be a potato. You give me, $100 million, and I can do something more sophisticated. And so this is the kind of stuff that you have to be thinking about, is will your architecture support your use case? So like things like with this, a local server has high upfront costs, but zero unexpected scaling costs. So think about if you're with a startup company, right? And your startup company has $1 million, but they don't know where they're going to get their next funding round. One of the things you have to be thinking about is at scale. What happens if your company takes off? What happens if you are the next Facebook? You're probably not going to be. What if it is, right? So you go and you use some kind of API setup. So you're getting charged a fraction of a cent every time there's a request. Right? If this is a lab environment, or if you only have a few people using the system, that's not going to be any big deal. If you become the next Facebook, though, and your system starts getting hammered to high hell and back, you can literally bankrupt your startup company simply based off of all of that utilization, right? So by going with an API, the nice thing is you have an incredibly low upfront cost, but the scaling cost may be exponential. Where if you go with a local server, right, building a local server with Ollama or some other kind of system in order to run an LLM, it may cost you $10,000 or $20,000 up front. You put it into something called a co-location facility that's going to cost you another $1,000 a month. But that's it. You don't have to spend any more. Even if your system gets hit to high hell, the worst case scenario is that your server is going to crash. And sometimes you prefer your server to crash rather than get the bill from OpenAI. So it's a thing to think about. APIs, again, can scale along with your credit card. So if you have a hell of a lot of money coming in, you can simply keep swiping your credit card in order to get more service, right? Let's see here. Depending on your situation, if you're doing something, let's say for a local facility, a local building, if you have an LLM that's on premises, even if the internet drops, even if AWS screws up their DNS and takes out every other thing on the internet, if you have a local server, everything will keep running. Whereas if it's up on the internet, you'll have a problem. APIs don't require server administration. This is a big thing right now, right? There's a lot of Node developers. I give shit to Node developers just because they give me shit. But anyways, a lot of people have forgotten that server administration takes time and energy. right? So if you build your own Olama system, I literally had a consultation with somebody, and I got very confused because he ran a business. He ran a real web business that paid his frickin' mortgage, the whole 9 yards. And he was asking me about how to host his server locally. So I was like, yeah, I just want to host my server out of my house. So we go through this whole thing about port forwarding and the whole 9 yards. And then I'm like, wait a minute, so what server do you plan to run at your house? And it was the server that's running his entire web application for his business. And I literally had to ask him, is $5 a month that you're going to save by not paying DigitalOcean really worth the chance that the power is going to go out in your house, your internet connection is going to go down in your house, and the whole 9 yards? The other thing too is like when you're running your own server, CPU fans really do fail every once in a while. Again, back when I actually used to do computer repair work, it's amazing when you're like, I wonder what's wrong with this computer. And then when you pick it up, you hear something bouncing around inside. And it's literally the CPU fan that, like, for some reason, like burned off the motor. And so the entire thing crashed. Dun, 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 dun. Yeah, yep. Where did that person go? Person. There you go. Oh. Guys, have me running around today. 6 o'clock is the start. Okay. So things to be thinking about. Another thing with the APIs, this is going to be something that's going to be very important going into the future, because in the technology world, there's something called obfuscation. So a lot of times, we talk about things like transparency, like how much you understand, how much visibility you have into systems. And so you hear about things like encryption. So encryption is where you try to give people no visibility into what's going on. One of the issues we have right now with a lot of technology companies is they don't do encryption. They do what I call obfuscate, what everybody calls obfuscation. They tell you what they do, but they tell you it in such a way it makes it very confusing to understand what it actually is that they do. And so this is something you have to be careful about when you're using APIs, especially if you start actually working at a company where what you do and the information you process matters. Remember, whenever you send data out of your system to an API, you genuinely do not know what the hell the other person is doing with it. Right? You are told, right? You are told we don't log. You're told we do not train on your information. You're told a lot of crap. Unless you actually have the ability to audit that information, you really honestly have no idea what's going on in their systems. The other thing to be careful about right now, especially with these AI companies, is they tell you specific things to pat you on the head to make you feel more comfortable, right? We do not use your data to train the systems. That sounds very good. Here's the interesting thing. One of the things we learned from the NSA is that metadata can be very valuable. Information that is not the data itself can be valuable on its own, right? So if you're dealing with a company, I don't know, something that might be important for investments or anything else, if they know where the traffic is coming from, if they have an idea of what that traffic might look like, and then they start getting a spike in traffic from your site about certain things, they know something important is happening on your site, and that might be valuable on its own. This is interesting. Again, I used to do work when I did my work in Baltimore City, and one of the curious things I found out was the waste disposal business apparently is one of the most brutal businesses out there. I would have never known. Like the people that take your little dumpsters or whatever, those people are apparently bastards. Like they literally break into each other's offices and do all kinds of like high-level espionage and stuff. And so it is something just to be thinking about, like with APIs. What information could be leaking from your systems that you're not realizing, especially as you use these AI systems. One of the things to think about, again, with architecture is things like caching. So we're going to have a class on databases coming soon. And basically, when we talk about caching, so you're going to have your server, and your users are going to be coming to your server for these AI requests, right? So initially, when an AI request goes out, it's going to go to OpenAI. So the request is going to come out, and the response is going to come back, right? And so this is going to cost you, a fraction of a cent in order for that to happen. Well, the thing is, if you have a lot of users coming to your AI system to ask questions, many times they're going to be asking the exact same question. So one of the things you can do is a caching system. So basically, you can create your own database server. When a request goes out, the request goes to the database server. When the response comes back, the response comes back. So it keeps the request and it keeps the response. right, in the database server. In the future, what happens if the user goes to your AI can query your caching server first to see if that request has already been made. If that request has already been made, you can pull from that local database server without going out to OpenAI or an AI system. Whether this is a local AI system or whether this is an API, this is going to be a hell of a lot faster. It's going to be less resource intensive. It's not going to cost you any money, and you don't have nearly as much information going to OpenAI, right? If you have 50 people asking the exact same question, OpenAI sees that once. So that might be a valuable thing for you. And this is the kind of thing you need to be thinking about with architecture. Let's see here. One of the big things is AI drift. Be careful about this. I don't know how bad this currently is. So I've been teaching this type of class now for about 3 years. AI drift, like 3 years ago, was horrible. What AI drift is as far as you have been informed, it's the exact same model. You're using 3.5 turbo, and you've been using 3.5 turbo for the past 3 months, and so it should respond the same way it's been responding for the past 3 months, except it doesn't, right? So I saw this with OpenAI, so I created this original class like 3 years ago. I do it 4 months later, I take it off the shelf to do it again. You always test your scripts before you do the class, and all of my scripts didn't work. I am pinging the exact same model I was pinging before, basically looking for the responses to come back so I can parse those responses. All of a sudden, those responses are actually different, which means all of my code broke. So one of the things you do have to think about, so if you have a local LLM model, that model will only change when you actually change it. When you use these APIs, the model will change when they decide to change it. And this is something that you do need to be careful about. How will your users be interacting with your AI system, whether they'll be going through like web app, mobile, voice. These are things you need to be thinking about with your architecture. And then what will happen with your returned responses. So with a lot of the responses that we're going to be doing today, we make a request, we get the response back. It basically gets erased as we make the next response. One of the things that you're going to need to be thinking about is, are you going to be storing these responses? Do you need to store these responses for legal reasons? Do you need to store these responses just for management reasons? If you store the responses, do they need to be in an encrypted state? That type of stuff. That's the kind of thing you need to think about. Again, we talk about databases. So there's a database that we like to use. We're going to train you guys on here called SQLite. SQLite is fantastic. It's easy to use. It's just simple. And the nice part about it is there's no administrative overhead. You just use it. The problem is you can literally just copy and paste it somewhere else and somebody can open it up. It has like negative security. So if you were doing like a D&D character, its armor class would be like -500. Like you just look at it, the damn thing would die. And that's the kind of thing that you need to think about. It's like, okay, well, I'm going to be storing the data into a database. Okay, fair enough. Is it going to be a SQL or a relational database, or is it going to be a NoSQL database? Is it going to be SQLite? Is it going to be Postgres? Is it going to be MySQL? These are the kinds of things that you need to be thinking about. And this is what goes into an AI system, not just using a prompt. Okay, any questions up until that point?
I think I did something recently where, in order to your opinion, you almost need something, maybe another small LLM, if you're caching the request.
Yeah.
And then I ask, you need something to say that that's close enough to retrieve the response. Any thoughts on that?
Yeah, that will go into different classes. So there's something called the general idea there. So like there's vector databases. So vector database kind of trying to guess you close. It's like how statistically close is this to something else? There's also something you can use diffs. So there are diff modules in Python, and you can say if this is 95% similar to another, and it does all the processing for you. Yeah. Yeah. So you can do that. Okay. So the first thing that you're going to need to do is an OpenAI account. Let's see here, things to think about. So I'll give you the warning first. Again, OpenAI changes significantly over time. So far, there's not much that is too dramatic, but it may cause a few minutes, hours of troubleshooting if you have not used it in a while. One of the problems with all of these AI products that are out there is this idea that they are mature products, right? You hear Sam Altman talk about spending $4 trillion on CapEx expenses for data centers, and it sounds like we know how AI works. This is how AI works. And the thing is web infrastructure, right? Email, we know how email works. SMTP, a lot of stuff, we know how it works. AI, they're still kind of figuring that out. Which is fine, which is fine. The problem is they sell it as if it's a mature technology. And then what happens, especially when you go into your OpenAI account and you haven't looked at it for 2 weeks, is a lot of things have changed. Again, simply doing this class over the past couple of years, how you process the responses that comes back. It's changed, how that's changed, how the modules work change, how a lot of different things work change. And so this is just one of those things to keep in mind when you're playing with this stuff. This can be an issue for you if you're working with clients and you don't deal with their systems for a while. So if you're the AI person in your company and you're opening this every day or two for your company, you should be fine. Things change, whatever, they all do. The bigger problem is going to be is you build something for your client last year, and then something starts going buggy now, and then you open up and you start looking the code and you start trying to match the code towards comparatively how they're doing things now, and there might be some really wiggly things going on. So just kind of be careful with that. Yep. So if we go and we take a look at this, we can look at the OpenAI API. So basically, let me see if I do this. Control, take me there. Okay, so in order to get to this, you're going to need to go to openai.com/API. And so that is going to get you here. And so this is how you're going to access the API. You're going to go to log in. I'm already logged in. So again, they have ChatGPT. That is not what we are using. We are using the API platform. You come to the API platform, and then it's going to give you a page like this. They're actually very good with their quick start guides, as long as you understand Python. You do have to have an understanding of Python to understand what's going on, but if you have an understanding of Python, most of the quick start guides are really good. They give you the recipes for how to build stuff, and you can basically run with it pretty easily. So when you first come in here, it comes to the docs section, and on the docs section, you can see we have a quick start guide. Again, creating API keys and doing other kinds of things. They talk about the models, they talk about the pricing, and then they have the core concepts. So they have text generation, they have image and vision, audio and speech, structured output, function calling, and different things. So basically you can come here, even if you forget everything I teach you in this class, and you can go, okay, text generation, and this is the basic idea. This is all you need in order to do the OpenAI call. Oh, OpenAI? You are late. You are late. Okay, come on now, come on now. Oh, I need to start creating Fs. Okay. Dun, dun, dun.
What's the Wi-Fi?
It is right behind you. Okay, can you hand that to her? Yep. There you go. Nice full class at least. Okay. So you can come here, and this will give you all the basic stuff. And this is what I talk about. Like, people think it's a joke when I say AI is hard, APIs are not. And this is the big thing to understand the technology world. So anybody that's not been in the technology world for a long time, you do not have to be smart to do this field. You just have to be precise. As long as you put the periods and the commas and the semicolons in the right place, you're going to be doing a fine job. And this is all it is. Like the people who created this LLM are freaking geniuses. I am not that smart. I mean, you don't have to be either. You just have to be able to do 1, 2, 3, 4, 5, 6, 7 lines of code. If you can do 7 lines of code, if you can copy, paste, and slightly modify 7 lines of code, you can be using high-end artificial intelligence systems. So anyways, this is basically all there is for the text generation. And then it gives you an idea of what the response looks like down here. So that's what's here. If we go up to our dashboard, this is going to be the important one. If there is one thing, wait a minute, I don't want Durham. I want to go to Manage Projects. So go to your dashboard, and then go to Manage Projects, and then the first thing I want you to do is I want you to go to Limits. Go to Limits. There's one thing you remember this entire class is go to Limits. In your limits, you can edit your budget, and you can put a budget. So you folks can do some stuff tonight. I put my budget at $30. So that if one of you does a wild true loop, I'm only out $30. But anyway, so you can put the budget here. At 20% utilization, it can send you an email, and 100% utilization, it can send you an email. So this is going to be the big thing. And this is your organizational budget. So for your entire company, your entire organization, you will not spend more than $30 a month. So this is where you have to go to your CEO, you have to go to your executive. You can say, Daddy, how much money do I get? Mommy, give me more money. And they say, we'll give you $1,000 this month. And then you plug $1,000 in here, and at least you know you won't go over that amount of money. Past that, then you can go down to individual projects. So you can see I have projects. There's default project, another project, Durham Clus, because I'm horrible at typing stuff, and test project. So I'm in Durham project right now. And then what I can do is I can come down here, and this shows me the limits of this particular project. And I did not set a budget. So I can come in here, and I can set a budget, and I can say, please don't spend more than $15 of my money. So this is one of the things you can do, again, with lab environments and production environments. It's a way to give you some money to play around with. Beyond that, here's where we have the admin keys. So if you want to create a project, you can click on this Create a Project link. Once you've created a project, you can come here for API keys. So when you do an API key, you can see I have this class key here already. All you do is you do create new secret key. You plug in whatever. Show the class. So this is my key. You can do restrictions. So you can basically say what they're able to do or what they're not able to do, a security thing to be thinking about. And this is the kind of thing, again, that we get paid for, is right, okay, we want to visualize, we want to think about all the stupid things that our employees might do. How can we build security into our systems to keep them from doing the stupid things? And so if I put security on my keys, then even if they do start trying to create images or something that they're not supposed to do, they'll be prevented from doing that. So you can come here and try to create that security. Let's see, test key. You can select the project for it, so test another Durham class, and then I can create the secret key. Now the big thing is, this will be the only time you are ever shown this key. As soon as I hit done, you will see the end part of the key. That's just a way that you can track it, but you will never get this key from OpenAI again. So basically, this is where you copy, you paste it into a safe location, and then you go from there. Because as soon as I hit done, there's no way to get that back, right? Even when I come here, I can change permissions and things, but I can't get the key back itself. So that's just one of those things to kind of keep in mind. Let's see here. You have limits. This shouldn't be a big problem for you folks, again, unless you guys create the next Facebook or whatever else. This shows you for the different models, GPT-5, Mini, Nano, O3, the whole 9 yards. It shows you the token limits. So when we talk about tokens, 1,000 tokens is approximately 750 words. A token is either a word, a part of a word, or a symbol. Basically, the LLM breaks down whatever you send it into these tokens, turns it into a whole number thing for it to deal with it statistically, and so that's the thing to be thinking about. So with this, like if you're using GPT-5, it can deal with 1 million tokens per minute. So that's, I don't know, 750,000 tokens per minute. So you're probably fine with that. You have request limits, so 5,000 requests per minute, and there's this whole batch thing. So all of this should be fine for you. If you go to other models, you might run into some issues. 500 tokens per minute. There are some smaller ones. Like here, I mean, it might be a weird thing, but if you do mini search preview, you can only do like 45,000 tokens per minute. So that's just one of those things to kind of keep in mind, depending on what your project is doing, how much you're dumping into it. So if you're dumping entire books into your LLM, you might run into these particular limits. If you're doing labs, you're not going to run into these limits, but it's something just to kind of keep in mind. And then the other thing too with this is you do have to be careful with how much OpenAI will allow you to spend per month. So currently my usage limit is $500, right? Since I have like a tier 3 account with them, I don't spend that much money. They max me at $500. So something to consider if you're about to put this system onto something that's about to go into production, it's going beautifully for about a week and then everything dies. You may literally have just hit what their particular limit is. So be careful there. You can see down here, increase your limits. This tells you some specific things on how to increase your limits. So just kind of keep that in mind. With that, is there anything else? Oh, one of the interesting things, if you go to the projects, oops, let's see, dashboard. One of the cool things is this. So if you go to your class project and you go to the dashboard, they have create a chat prompt. So again, one of the big things is creating prompts so that the LLM can provide you the best answer possible. And so one of the interesting things is you can come here and you can ask it how to create the best prompt possible. It can do its own little prompt engineering. So, I don't know. So it's a chat prompt. Tell me a story about frogs and unicorns. I don't know. I guess that was a little complicated for it. Okay, there we go. Tell a creative and engaging story involving both frogs and unicorns. A story should be imaginative, including both types of creatures, blase, 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 blase. So this is a way, again, I'm weirdly not this creative. Like when I just put in prompts, I put in very simple prompts. And the interesting things with these LLMs is the more complex the prompt you put in, the better the response you're gonna get. So one of the cool things here is you can give it a pretty crappy prompt and then it can give you this nice verbose prompt that will hopefully give you a lot better result. So this is something that you can use that's there. There's a lot of other things here like storage, logs that can be useful. So if I go to, I think it's test I've been using. Isn't it test? Maybe it's class. Default project. Right, 1 cent joke. Completions. There is logs. Is this gonna give me what I want? There we go. And this is one thing just to kind of keep in mind so that you know this exists. So, I've been putting these requests in, tell me a joke about Eli, the computer guy, in under 20 words, write a 1 sentence joke about Louis Rossman. And so this actually shows the outputs too. So this is a way that you can see what your users are putting into the system to understand if they're using it properly or not. So this is something that does exist. So this might be useful for you to make sure people aren't putting in like personally identifiable information or things that they shouldn't be putting in are there. Yep, and that's basically the idea with the dashboard and all that. It's one of those things you just got to go play through. It's like all crappy dashboards. You just got to figure it out. Any questions on the dashboard?
So that log, and then you have a prompt up there, because where you are right now, that's coming off your tokens. But you also mentioned you have like a regular one.
What's that? No.
OpenAI comes in 2 flavors.
Yep.
The monthly free, which is
Yep.
use that up.
Yeah.
And then the per month, and then the tokens. So
Yep.
I can understand how Python's using tokens.
Yep.
But when you were sitting in that chat window, because of where you were located, is that using tokens, or did that kick into your?
Oh, did that thing? So when you're doing this chat builder here, this, I don't think they charge you for
It
this.
doesn't matter that much, I guess, because you're not doing that.
Well, and it's all, you're not actually, I don't think you're doing like a real request. Because basically they want you to do a better prompt. And they're going to make more money off of this really long prompt than they are off of my one crappy little sentence. Yeah. So as far as I know, you don't get charged for this.
This is the prompt, but I guess that costs that.
Yep. One of the things though too to be looking at is the pricing. Oh, how do I get to my docs? Docs, pricing. So this is going to be a big thing to consider. Again, with different models. One of the things you want to do is you want to use the best model or the cheapest model that's going to provide you the best response. So this is where we look at the different pricing. So pricing now is price per million tokens. So this is pretty insane when you really think about it. So if you use GPT-5, GPT-5 is their best LLM model now. So the input is $1.25 per million tokens. So that means you can put 750,000 words into it, and it's going to cost you $1.25 input. Where it might get dangerous, though, is the output is $10 per million tokens. So you put 750,000 words in, and that costs you $1.25. If you want 750,000 words out, that's going to cost you $10. This becomes very important when you think about processing information. So there's something called context engineering now. So it used to be prompt engineering. So prompt engineering is how to ask the best question of an LLM to get the best response. So now when we talk about context engineering, what that is where we use something called RAG. So again, basically RAG is a database system. We use other systems to bring information in to our request and send that to ChatGPT. You need to be thinking about what you're doing. So I've shown you folks this in the last class. We're going to have a class on web scraping to explain this a little bit better for you folks. So one of the things that you can do is you can scrape a web page. So I can use something called the request module. I can go to a web page. I can grab the entire web page. I can send it to ChatGPT and ask it questions. The thing is, when you grab an entire web page, you're going to be grabbing the CSS and the JavaScript and the XML and all the crap you don't normally see. So a 500-word blog post is going to end up being 30,000 words. So what you can do is you can use something called Beautiful Soup. Beautiful Soup will go in, it's a module, it will grab just everything in the P tags, so now you're just sending 600 words. So this can be a dangerous thing now. It's the whole question in the technology world, is something good or something bad? So the context windows, so the amount of information you used to be able to send to ChatGPT used to be limited to 4,000 tokens, so about 3,000 words. So worst case scenario, you're going to get charged about 1.5 cents, even if you did something stupid. And if you tried to send more information, it would just fail out. Well, now they've made the system better. You can send 1 million tokens in one context window, which basically means if you're not thinking about it, you might start getting billed $1 or $2 literally per request because you simply sent way too damn much information to their LLM. So this is the kind of stuff that you do have to be careful about. So you look at GPT-5, it's $1.25 in, $10 out. If we come down to like their Nano, so their Nano is supposed to be a faster, better model. It's $5. I'm not sure I trust these, to be clear, I'm not sure I trust these numbers. This is what they say the numbers are, but who knows. They say it's 5 cents per million tokens. That seems really low going in and 40 cents out. So look at the price difference. GPT-5 is $1.25, Nano is 5 cents. So literally, if you can get a better response out of Nano, use Nano. And they have all these different ones. So they have a lot of different models that are available now. You can just go through here and, again, try to test around and pick which one will work best for you. One of the big places where you'll really get dorked up a little bit is things like images. Images start costing a lot. Image tokens kind of get confusing to see here. We're going to use something called DALL-E 3 today. And basically with DALL-E 3, with their image generation, for standard images, for standard 1024 by 1024 image, that's going to cost you 4 cents a piece. For a high definition, it's going to cost you 8 cents a piece. And if you go for a larger one, it can cost you 12 cents a piece. So if you're sitting there and you're like, oh, I'm going to create a little AI image generation app, just realize, depending on how you code it, it might cost 12 cents every time you hit go. And so what can your credit card afford? And that's one of the things to be thinking about. So just kind of something to keep in mind. And that's where, again, with testing purposes for you folks, or if you're trying to demo something to your executives, there's something called DALL-E 2. DALL-E 2 is amazing for the nightmare fuel that it creates. It is horrible. It is a garbage model for creating images, but it creates some very interesting ones. The important thing to understand here, though, is you're paying a tenth of a cent every time you get an image. So instead of paying 4 cents, you're paying a tenth of a cent. So if all you're trying to do is demonstrate a concept, again, that's where you might want to be using DALL-E 2 instead of DALL-E 3 if you don't really care. It's like if all you're trying to do is I want to be able to make the request, I want to be able to receive it, I want to be able to download the image, I want to put it into a gallery, I want to put stuff into a database, I want to prove that this is working. Again, you can save a lot of money simply by the model that you use. So anyways, that's pricing there. They got legacy models, all kinds of stuff for you folks to flip through. So that is pricing. Questions on pricing or anything? Nope. Okay, cool. Now let's get to API keys and environment variables. Okay, so we are going to be on page 6 for this. So how you are supposed to use your API key for OpenAI when you use it is you're supposed to use it as an environment variable. So if we go and we look at the code that I've been creating, you will see what I've been using in the projects for most of the projects today is this. Right? So here's the module, here's where we import OpenAI, and then here's we plug in our API key. Now I do this, so whenever I teach Silicon Dojo classes, the goal here is to teach you the concept. One of the big problems I see that a lot in technology classes is they try to teach you everything at once. They try to teach you the concept, and they try to teach you security, and they try to teach you everything else, and it gets very confusing and you don't remember any of it. So when I teach classes, all I really care about today is that you understand how the OpenAI API works, and so that's why I'm putting the key here. But think about this. If I hard code the key here, and then I decide I want to share this work with all of my friends on GitHub, and I upload this to GitHub, I now have just publicly published my key for the world to see, for somebody else to scrape, and now for somebody to use, basically my account to do their AI request. So this is normally not how you do it. Again, the only reason we're doing it this way today is just to show you folks the easiest way to make these calls work. If we go to the environment, the proper way to do this is you're going to use what's called an environment variable. So what the environment variable is within your operating system, you can set what are called environment variables, and then your Python script can pull those environment variables. That way, it's pulling the environment variable from an external source, it's saving it, it's kind of in its own internal memory, and you don't actually publish it anywhere. You don't actually see it anywhere, right? So the easiest way to do this, especially in a testing environment, is we use a module called .env. So what you do is you create a .env file. In your .env file, you create a variable name. So OpenAI _API _key equals, and then you plug in your API key. So basically now all you have to do is remember not to upload your .env file. Just never do that, right? When you plug in your API key here, just remember syntax. Notice there are no quotation marks around this. It is simply equal and your API key, and that's it. If you put quotation marks around it, all of this is going to fail. So just keep that in mind. Then basically what happens is you come here. So in order to do the script, we're going to talk about the script more in a little bit, but this is just to show you how the environment variables work. So we do from.env import load.env, and we're going to import the OS module. We're going to do load _.env, and then we're going to do override equals true. So one of the big things you have to worry about in the programming world is something called caching. What caching is when your computer stores things into memory, and so even when you make a change, it is still pulling what it remembers, what's in the cache, instead of what your change is. So when you do override equals true, this means pull in the environment variable, don't use the cached information. And then what we do here is we say API _key equals, we use the OS module, get environment variable, open _API _key. So here is where we created that variable. Then we come here, we load the environment variables, we grab that environment variable, we set the value to API key, and then we feed it here. So client equals OpenAI function, API key equals API key, and that's how you're able to do this with environment variables. Again, we're not doing this in the rest of the class because this just adds a little bit more complication that frustrates everybody, but this is how you were supposed to do it. Any question on environment variables? Nope. Cool. Okay, so then we go to basically just the normal way of doing it. So OpenAI key. So basically with this, instead of going through all that environment variable stuff, you'll notice, so we don't have to import the OS module, we don't have to install .env, we don't have to do the rest of that. Basically what we're going to do here is we simply create a variable called key. We then set the variable to our API key. Do see that here there are those quotation marks because we are setting an environment variable within Python. So within the .env file, no quotation marks. On Python, you have to use the quotation marks. Then all we do is down here, we simply feed client, so OpenAI, API key equals key, and so that is going to be the API key that goes in, and that's what we're going to be working with. Any questions on API keys? Yeah, okay. Let's see. So now let's actually start looking at the text generation. Question?
So where are the .env files usually kept?
So you create the .env file.
Right, I'm just saying, like, typically, like, in real systems, where do they store those kinds of files?
So the information would be stored in a database. So basically you would have some kind of subroutine to go into the database, grab your API keys, set them as environment variables, and then your script would then pick them up. Because basically, especially if you have scripts, if you have programs that are going to be continuously running, there's something called API key rotation. So the idea, theoretically, from a security standpoint, is you should not keep the same API key forever, because the idea is at some point it will leak. So you rotate your keys, maybe every month, maybe every couple of hours. It depends on what you're doing. So that is where you would create a subroutine where you would have a system to do this API key rotation, and then your script would periodically then basically essentially renew the API key to keep everything going. Again, that's its own big, nasty old system.
Nice.
Yep. Okay, so there we go. No, not where we go. Where are we going? There we go. Okay, so this is our first thing. So basically we're going to be doing a text generation with OpenAPI, and this is basically all there is to it. Now the big thing is when we get the response back, so it's going to say response equals client.response.create. This is always going to be the same. You're going to put the model in here. So where I showed you those different models, this is where you tell it what model you're going to use. So we're going to use GPT-5. So we're going to put that there. And then this is the input. So we're going to say, write a one-sentence joke about Louis Rossmann. So anybody here know who Louis Rossmann is? Okay, you all know about my frenemy relationship with Louis Rossmann? Okay, we're always going to be a smart ass towards Louis Rossmann. If you don't know who he is, find out who he is. He's a good guy, but we're still going to screw with him. He did passive-aggressive cat videos about me 5 years ago, and I will never forgive him for that. Anyways, so all we're going to do here is we're going to put in what our query is. So write a one-sentence joke about Louis Rossmann. And then we're going to come down here, and we're going to look at the responses. So the response that we're going to get back is going to be what's called an OpenAI object, right? So the first thing we're going to do is we're going to print back this entire ugly response. I'm just going to show you what it looks like, because the important thing is there's actually a lot of information in this response other than simply the response that we're looking for. So what we want is the joke. But there's going to be a lot of other things in there. There's going to be things like how many tokens, the input tokens, the output tokens, the total tokens, some other information. So again, something if you're going to be tracking your system, right? If you want to track how many tokens individual users of your system are using, but you can pull that additional information out too to verify what's going on. So basically what we're going to show you here is we're going to print response. That's going to be the entire response object. We're then going to use shortcuts. So this is weird. This is weird. So when you're pulling responses, normally you're going to be using like lists and what are called lists and dictionaries. So you use indexes or named indexes, 0, name, that type of thing. So square brackets, square bracket 0, square bracket inside quotation marks, name, or whatever else. That's how you normally do things. Here, or they do classes. So with OpenAI, with Ollama, everything gets responded to in a class. So it would be like response.output. But you can look at the object and you can know what the hell you're looking at and be able to get to it very easily. One of the weird things with OpenAI is this special because everybody's special nowadays. They've got to do their own weird things. So what they do is they use what are called shortcuts. So within their module, they've created these shortcuts to point to specific things. So if you're trying to get something like the output text, you're trying to get the total tokens or something else, instead of simply, like you can look at the object and understand the information that's coming out of the object, but in order to actually access that specific information, go to ChatGPT and say, what is the shortcut to get the specific information? And then it'll go, boop, do that. Anyways, so let me show you this. So we're going to do a joke about Louis Rossmann. We're going to do a joke about Louis Rossmann. There we go. Pop, 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 pop. It's not that fast. Okay, there we go. So the first thing that we're going to get back, if we look at the script I'm showing you on page 8, is the first thing is going to be this really ugly response, right? So it starts here. It says response. It gives you an ID for the response, so you might want that for some reason. And then it goes through here, and it's just a lot of different things. So down here it says content, response output text. The text of this, Louis Rossmann walks into an Apple store, and the no user serviceable parts inside sign quietly turns itself off, right? So that is the text that we're looking for. So normally, if we're parsing things normally, we'd say like response, again, as I say, like square brackets 0, square brackets text or something else. That's not how you access this. So this just kind of shows you that this is here. It shows you some other things like the temperature that was used, if you care about temperature. It gives you, let's see here, input tokens. So it shows you 16 input tokens were used, output tokens were 415, total tokens were 431. So I spent a fraction of a cent, 431 on this. Yep.
Is that response standardized? Because as I understand, they're charging you for characters or tokens that they're coming back as an output, right? So is there a way that I can configure so I just want the text or eventually just the information that I need, not the whole?
No, so this is going to be the response that you get.
It's a standard. I just always want to get the whole package.
Yeah, you're going to get this whole response. Again, 431 tokens. So 431 tokens equals about 300 words. So yeah, maybe this actually all is part of that. But yeah, so yeah, you're just going to always get this back. So how you get what you actually want, so this is the text that we actually care about, and that comes from this shortcut here. So response is going to give you the whole object, response.output_text. That is just going to give you the text itself. And so that's where we have this here. Louis Rossmann walks into an Apple store, and the no user serviceable parts inside sign quietly turns itself off, right? So that's the response that we're actually looking for. And then down here, again, if we wanted the total tokens used, this is where you can get that total token information. Again, if we want to dump that into a database to track it for whatever reason. Does all that kind of make sense?
So there is there's like an output tokens and there's like total tokens.
Yep.
So they charge you for all that metadata that comes back?
Yeah, it appears so. Again, the questions you get in class you never really thought about beforehand. Yeah, so there's the input token. So if you look at it here, I mean, it is interesting. Like now, so you can see 16 input tokens. So that question was turned into 16 tokens. And then if we look at, oh yeah, so it says reasoning tokens. Okay. So yeah, this is where you have to, again, be careful. So they're saying that they used 384 reasoning tokens. So again, that's where you got to go and again, flesh this out and figure out how it all works. Again, for things like testing purposes, it doesn't really matter. Again, this cost me, I don't know, this cost me 1/100 of a penny to do. It is one of those things in a production environment, and that's where you have to kind of consider what's going on. Yeah. Okay. More questions, more for me to learn about going forward. Okay, so any questions on that? No? Okay. If anybody needs a potty break or whatever, just tell me. I am extremely long-winded. Okay, so let's go to model testing. OpenAI models. Okay, so this is going to be a way for you to test the different models. So as I said before, all these models are going to give you different responses, and they are going to cost you different amounts of money. And you're going to be told things, you are going to be informed things that may or may not in fact be true. And you've got to test for whether or not they may or may not be true. So basically what we have here is we're going to loop through, and we're going to do a loop. So we're going to do one request, and then we're going to run it through 3 different models. So GPT-5 is that best model, the most expensive, the slowest model. GPT-5 Nano is supposed to be inexpensive and, we are informed, fast. We are informed it's going to be faster than GPT-5. Is it? And then there's GPT 3.5 Turbo, which is what I used to train people on. So basically, we're just going to run it through these 3 different models to see what the responses look like. And so that's going to be an important thing. Do a lot of testing, figure out which model for the least price, for the best performance, gives you what you actually need. So basically with this right here, we're going to have this while true loop. So again, a while true loop is a loop that is going to continuously run. Be careful with how you do these. I do these, it gives you a nice little user interface. So you can ask a question or you can make a query, it can give you a response, then you can make another query, make another query, make another query. But if you don't do it right, you could just ping the hell out of OpenAI's API and run up your bill. So we have this input function here. So input function is going to ask what is your query. That value is going to go to query. I'm going to print the query out on the screen. And then we're going to send to the AI function, we're going to send this query value. That's what's going on here. Up here, we kind of have an ugly, this is what's called a function. So we define the AI function query. We're going to create a list. And so this list is going to have GPT-5, GPT-5 Nano, GPT 3.5 Turbo. So what we're going to do is we're going to run this query against these different models. One of the things I've also done here is I've imported the time module. So what the time module does is it allows us to actually have time within our script. So I want to time how long it takes to process using these different models. Again, which is going to give you a curious response. So we're going to do what's called a 4x loop. So for version, so we're going to call each of these in here a version in model. So the model is the list. And then for each one of these values in the list, we're going to call it version. Speed equals time dot time function. So this is going to give us the seconds. It's going to tell us what the current time is in milliseconds. So we're going to say response equals client, response is create. Model is now going to be version. So whatever is here, we're going to run that model against the query, right? Speed is going to equal time dot time. So whatever the current time is minus what the previous time was, and that is going to be how long it takes for this thing to process. We're then going to print out what the version is. We're going to print, this is called concatenation, it's called an F string. We're going to say the speed, so how many seconds it took, and then we're going to print response.output text, so what the response is, and then we're just going to print a line. Does that all kind of make sense to everybody? Okay. If it doesn't make sense, ask a question. So we're going to run this now. So what is your query? Let's see here. Joke about Louis Rossmann, because I want to just not give it up. Okay, so we're going to say a joke about Louis Rossmann. Bum-ba-dum-ba-dum. Okay. This is something you have to think about with your systems, is how fast is this? Is this fast enough for your users? Is this fast enough for a class? Come on now. Because this is the Nano. Yeah, okay. What the? Yeah, okay. So again, that shows you the weird ass responses that you can get. Okay, and this is why you need to test, right? So GPT-5, the best of all models, took 8.13 seconds for a response. Again, something you have to consider, right? Louis Rossmann walks into an Apple store. The genius says, quote, we'll need to replace the entire laptop. Rossmann pulls out a microscope and some flux. Cool, now show me the 5-cent fuse. That made you say that. So if you know Louis Rossmann, that's actually not a bad joke for him. And that took 8.13 seconds. Now the curious one is I will have you notice the Nano model. So this is supposed to be the smallest, fastest. We were told it's the fastest model. Took 29 seconds and gives us all of this. And one of the things you need to be thinking about in a Python program, right, you need to be able to parse that response that's coming back. So if I have some extra spaces in the front, I can do a trim. If I have some other stuff, I can parse that pretty easily. If I start getting responses like this back, it becomes ever more difficult to be able to parse this into something that a user can actually handle. So this is one of the reasons why you have to test this stuff. So again, so now it's giving us like 6 different jokes for some reason. And then we come down to Turbo, supposedly like the worst model. Took 2 seconds. Why did Louis Rossmann refuse to play hide and seek? Because he can always find the problem. Haha, not a bad joke either, and that took 2 seconds. So this is something to be thinking about with these different models, is for your users, have them plug in what their different questions are, have them rate what the answers are, and figure out what the best model is. And also, again, like I say, for parsing, I'm telling you, for parsing, this is a frickin' disaster. Like, because the issue that you run into when you're doing tech work is there's something called hard fails. So hard fails is where it just fails. Like your API call fails. You make an API call, it fails. Okay, maybe the API key is wrong, maybe my function is wrong, maybe I'm just literally grabbing the response wrong, right? I know how to deal with that. The worst problem as a tech professional is what's called a soft fail. A soft fail is where it sort of works. You did get a response, but it doesn't quite look how it's supposed to look, and then how do you deal with that? And this is one of the things with these LLMs is basically what can get you a soft fail of you are getting a response back, but is it looking like what you need it to look like? Okay, so that's the idea of putting these different things through. Any questions with the different models? Cool, all right. Oh, where are we going next? Yep, okay, so let's go to image creation. This gets to be a little bit more interesting. OpenAI image. So I decided to use DALL-E 3 here. So there's a lot of different images. So GPT-5 is a multimodal model, which is actually pretty cool. So the idea is that it quote unquote understands the world. Again, when we talk about AI, it's not that. Everything, all the words they use is about intelligence. These things aren't actually intelligent. They just do statistical stuff. But the cool thing with these multimodal models is the idea is that they're supposed to be understanding. So if I tell GPT-5, theoretically, create an image of Louis Rossmann fighting Tim Cook, it should be able to understand who Louis Rossmann is, who Tim Cook is, and then be able to do an image based off of that. That's one of the things that's really cool about a multimodal model. So we're using a model here simply called DALL-E 3. And what DALL-E 3 is you can say, have a computer repair person fight a CEO, and it will be able to do that, but it doesn't understand additional context. The reason I'm showing you folks DALL-E 3 instead of the other models is for the multimodal models, I don't know how I feel about this. They literally want government identification in order to be able, even to be able to process those models. So when I went to do these things, it was like, verify yourself. I'm like, sure, I figure it's just like do my email or phone number they probably have anyway. No, they wanted me to take a picture of my photo ID and send it off to another third party. And I was just like, I don't know how I feel about this for a class. So that's why we're using DALL-E 3. Again, the GPT-5 multimodal models will give you far better stuff, quality stuff, but you've got to give them your ID. So the curious thing here, basically what you can do is, let's see here. Oh, okay, yeah, that's right. So what we're gonna do here is up at the top, we're gonna do from OpenAI, import requests, and import time. So the big thing to understand is when you make this request to get an image, it is simply going to provide you a URL. So the image is going to be created and it's going to be dumped into an Azure data store. The important thing, be very, very careful about this. This is simply a temporary data store. It will save that image for approximately an hour, right? So it'll give you the URL to the image, and while you have the URL to the image, you can put it into a gallery, all kinds of different stuff. But after about 59 minutes, that image will disappear. So if you want to save the image, you actually have to download the image if you don't want it to disappear. So that's why we're using the request module up there. And then I'm importing time, because when you go to save a file in the Python world, you have to give the file a file name. It doesn't just take the name that it was originally provided. So I simply use timestamps as a dirt simple way to give it a name. I'll show you how that works. So we have our key as we've had before. We have the client as we had before. And this is basically what the prompt looks like. So we do result equals client.images generate. We say model, so we're going to say DALL-E 3. And prompt equals a person riding a cat. Under here, we're going to say the size. So there's a couple of different sizes you can have. This is a square, 1024 by 1024. Remember, every time I hit go, this is going to cost me 4 cents. So do be careful about this. So image URL is going to equal, so result.data at index0.url. So this is where the URL is going to be out of the full result. So we're going to print the full result just so we see what that looks like. We're then going to do result.data0 and we're going to do revised prompt. So we put this prompt in and then it's going to create an additional story about the prompt that we created in order to create the image. This can be very valuable for you for something called taxonomy. So whenever you're creating like blog posts or galleries, a big thing is how are you going to search for things, right? You save an image, right? You save an image into your data store. Well, now you've saved 10,000 images. How are you going to search for anything? So what's nice is if you have this revised prompt, you can save the image name into a database. You can save the revised prompt into a database, and then you can simply do a search. I'm doing a search on blue cats. And then you can say, oh, here's all the images for blue cats, right? So that's a nice thing about the revised prompt. And then we're going to simply print the image URL down here. Then down here, this is where we actually get the image. So image data equals requests.get the image URL and the content. So we want the content of the image URL. File name, this is concatenation, so an F string. So this is a little weird here. So basically time.time, so this is going to give our time in milliseconds, and then we're going to turn that into an int. So we just get one number there, and we're going to put that .png. And so that's going to give us a unique name. Because if we use the same name, we're going to overwrite any files that are already there. This gives us a unique name. So with open file name, WB for binary, write binary as handler, handler.write the image data, and so that will save, and we'll see that here. So you see these images here. Oh, these images are ones that have been created in the past. See a person writing a cat, and a person writing a cat, person writing a cat. See lots of different people writing cats. Anyways, so that's what this is. So when I run this, it is slow today. All right, there we go. Okay, so up here, this is going to be that full response, right? The first thing that we're going to print is the entire response, and we can see the revised prompt here. So this is a revised prompt. An Asian male wearing a casual outfit of jeans and a t-shirt with shorts. That's going to be there. We're going to have the URL. The URL, this is going to be where the image actually is, and that's basically the information that's provided back. We just want what the revised prompt is. So this shows us what the revised prompt is, and this shows us what the URL is. So blob on Windows. If I hit this, I can click on this and you'll see this opens up on the web browser. And so we have an Asian male riding a cat. And we'll notice here, if you go up here, again, this is actually on the web itself, up on one of Windows data stores. And so this will be here for approximately 1 hour. Again, at the 61-minute mark, it goes away, possibly before then. But since we have this little thing down here, right? This went out, that grabbed the image, that saved it onto my computer. So hopefully, that one, no, or that one. There we go. So that image is now actually sitting in the folder on my computer. Do remember with this, if you don't know a lot about Python, so this is going to save in what's called to your current working directory. So if you open up a folder in VS Code like this, whatever folder this will be considered your current working directory, and so it will get dumped into there. If you don't have this set up, this will be dumped into your root directory. So like with me, Eli, it will be saved into the Eli home folder. So just one of those things to keep in mind. So anyways, that's what we're dealing with. We're dealing with DALL-E, and it gives us some nice images. Just to show you how horrible DALL-E 2 is, just to show you the nightmare fuel. I know you're like, nightmare fuel, it can't be that bad. Let's show you some nightmare fuel. What do you get for a fraction of a penny? Okay, so for a fraction of a penny, you get that. That's not too bad. So you'll notice, DALL-E 3, you got photorealistic, DALL-E 2, you get that thing. So, yeah. But again, this is the thing to be thinking about. For testing purposes, this is completely fine. And this cost me, a 1/10 of a penny to do versus 4 cents a pop. Okay, any questions about DALL-E 3? Yep.
I wonder if DALL-E 3 is using another LLM to generate the extended prompt that it is giving.
That it's using which LLM?
I wonder how the extended prompt is getting generated.
Oh, by them, I think they just dump it through one of their LLMs. So I think basically, and that's one of the interesting, so if you ever watch, IBM is big for this around here, where they're talking about actually using multiple LLMs in a stack. They're one of the only people I hear talk about this a lot. And the idea is that you're actually going to use 10 LLMs to process something. And so I think with this, basically what they're doing is you put in your prompt, they do an injection to say, this prompt is going to be used for DALL-E 3, make it long, complicated, at least 100 words, and then that's probably what's giving us back that revised prompt. Yeah. But that is also a bit of their magic. Okay, so DALL-E 3, there we go. So computer vision from an image URL. So this is another thing that OpenAI can do that's pretty cool, is basically, it can have computer vision. So you can feed it either a picture or you can feed it a URL. Again, this is something you have to think about from an architecture standpoint. And then you can ask it questions about that image that it's seeing. So the important thing to understand here is I'll show you the two versions. So this is going to show you, you're going to feed it a URL for the image, and then it'll answer questions about the image. I'll also show you with uploading an image. Something to be careful about here, again, when we start talking about things like regulations and that type of deal, is how are you going to get the image to the LLM? If you have a data store that has URLs that's publicly accessible, then any of those images might be able to be scraped by somebody on the internet that finds them, right? So it's a simpler way for being able to connect the LLM to the image, but it's also a less secure way. So it's one of those things you kind of have to consider. But basically with this, pretty simple. Again, we've got OpenAI, import OpenAI. For here we have the query, so we're going to do the while true loop again to kind of give you this interactivity thing. Input, what is your question about the image? Response equals, we're going to send that query to the AI function. We're going to print what the query is, and we're going to print what the response is. We're going to come up here, and basically, just so you understand, this is all copy and paste. If you're like, I don't really understand why there's so many brackets and squiggles, you just copy and paste, you'll be fine. Anyways, but basically with this, we're going to do a response. So we have the function up here. So we define the AI function, the query. I just put the API key here to make it easier. We have the client like we did before. Then we have the response. Response equals client.response.create. We're going to put the model, so we're going to have a GPT 4.1-mini. So we're going to use that model to see what it says about the image. Role is going to be user. You're just going to leave that as it is. Here is where we feed in the query. So type input text, text. So this is either where the query comes in or where you hard code it. And then here is where you plug in the URL. So input image, image URL, and then here is where you put that URL in. All right. Then basically down here, since it's a function, oops, can you close that door for us? Or, yeah. There you go. Since it's a function, we're going to get the response back, but all we want is the output text. So response.output text, this is what we are going to return. That return is what's going to come down here and be set to response, and then we're going to print the response out. So this image, just so you know what it is it's a football game, right? So basically I can come here, I can run this, and I can see what teams are playing. So it looks at it. The teams playing are the Kansas City Chiefs in the red uniforms and the Buffalo Bills. So all it sees is the image and it's able to pull that out.
Can I tell you when the game was?
I don't know. When was the game? The image shows a football between, however, the image alone does not provide specific. Anyways, so you can say how many players? There are 16 players visible at the image. Right, so again, you're thinking about things like for taxonomy purposes, you could run a script against this to pull out this kind of different information. So like tags. Again, taxonomy, I'm all excited about taxonomy. I love architecture and taxonomy. So we can say provide 10 tags in CSV format for this image. Oh, there we go. So CSV, if you know what CSV is, American football, NFL, Kansas City Chiefs, Buffalo Bills, whole 9 yards. So again, like this is gonna be a big thing. So over the past 20 years, we've had digital cameras. I remember when digital cameras came out and everybody started taking all these digital images. And so we now have tens of thousands of digital images in organizations with no taxonomy. You just got piles of images. So what's cool with this kind of thing is you could feed all of these images to this LLM, pull the tags out, and now you can build a simple gallery type system so that your people can start searching for those images and actually have value there. It's one of the big problems we have right now with data. So over the past 10 years, there's been this fetish that has been like data is the new oil. We've all been told that data is the new oil, so everybody's getting more and more data. The problem is I talk with people in data companies and they don't know what to do with all this data. It's just getting stored places. So one of the cool things with these kind of LLM systems is you can start actually trying to pull value out of the data that you already have. Just to show you with these URLs. So you need the URL. So basically, you need the URL to go back to the JPEG file. So if you'll notice this is from CNN, and it has this long string that ends in .jpg. So I could say, I don't know, Elon Musk, I don't know. So do this, I can do a search, right? If I do images, what I'm going to be looking for is you can right click and you can say copy link. And just to make sure this link is decent, Control V. What you're going to be looking for in that link is not that. That will not process properly. So you're looking for something that has a JPEG. So I come here, okay, save image. So copy image address, that should be right. Control V, okay, see how that has JPEG in it? That's what you want. So we can hit Control C, you can go here, we can paste that in now. We can run this and say, who is this? No. Oh, okay. I don't know. Oh, provide tags for this image. Oh, TIGs. I'm a system admin. I'm not a coder. Okay, so man, business suit, profile view, formal attire. So it's seeing what's there. Maybe, oh, let's see here. United Nations. Let's see if there's some images from the United Nations right now with any people. I don't know. So we could say, let's see this. Oops, where'd the picture go? Oh, there was the picture. Anyways, let's see. So we do copy image address. Okay, so again, we just want that JPEG. What is this? So this image shows the General Assembly Hall of the United Nations headquarters in New York City, blase, blase, blase. So again, imagine if you have just a whole pile of images and you're trying to figure out what the hell all these different images are. It can be a useful thing. Any question for computer vision with URLs? No. You're all so quiet. Okay, so the next one is computer vision from a local image. So we're gonna have Roxy. It's my little puppy, Roxy. little chihuahua. So again, imagine you have local images, so you have a local data store. So the idea is being able to upload those images to the LLM to be able to ask questions about those particular images.
This video, you're going to be posting on your website?
The video here, yep, it'll be posted, yep.
My voice is like for Jack Bill, I'm famous now.
Yes, you're famous. You will get royalty check. You will get royalty checks of pennies for the rest of your life. Yeah. Okay, there we go. So we have our image of Roxy here. So basically, this is the same type of thing. We're just going to need to import the base64 module. So what the base64 module does is it is going to turn the image into a format that can actually be uploaded to the LLM so that it can process it. So we're going to go here, basically down here. How is this working? Okay, so we have the key like we had before. We have the client. We have the image path. So this is going to need to be the path to the image. So roxy.png is sitting in my current working directory. So all I have to do is put roxy.png. If it was in a different folder, you'd have to put the full file path to get there. Then basically what we're going to have here is we're going to say base64 underscore image equals encode image function, and we're going to do the image path. So the image path is going to be sent up to this function. It says with open image path read binary. So whenever you see B, that's binary. So that's going to be any file that's not text. PDFs, image files, video files, audio files, whatever else as image file. Then it's going to be return base.64, 64 encode, image file read, decode, UTF-8. So basically, to be clear, this is all copy paste. Eli, what does that exactly mean? Paste is what it means. Anyways, you just copy paste this, dump it in. And that is what's going to give you your base 64 image. So here, for response equals client response create, we're going to use the GPT hyphen 4.1 model for this. Input text, what's in this image? So I'm just going to hard code this here. Input image, so image URL, data, image, JPEG, base 64. And then here is where you put the variable name. So that encoded image, you put that variable name here. And then we're going to print out what the output text is. So this is the image. We run this. This image shows a small tan and white Chihuahua dog lying on a patterned couch. Behind the dog, there are several pillows, one of which is red with white lettering that reads camp. The overall scene looks cozy and comfortable. So that is the response. And that's not actually even the 5 response. That's a 4.1 response. So that gives you a pretty good idea of what it can do for you. So the big thing here is, again, when you're thinking about the images, we go back to that whole concept of architecture, is how are you going to get the image to the LLM? Are you going to have a web server that provides the URLs, that sends the URL to the LLM? Or are you going to have a normal data store and then you're going to be sending the images up? This is just something that you have to consider when you're building your systems. Any questions on computer vision? Oh, okay. Wow, we are going through this. Well, are we going through this? Hour and a half. Okay, so the next part is voice to text. Or text to voice.
I guess I have one quick question.
Yep.
On the image. Did you talk to that in Photoshop, like optimize it so it was smaller and could get uploaded faster or anything?
Did I modify that? No, I didn't.
Okay.
Yeah, actually, well, I did modify it recently, actually, so I could put it onto GitHub, because it was originally like a 19 meg image. I didn't really care. But to get to GitHub, I had to shrink it down. So it did get shrunk down, but it was for GitHub, not for... But that is one of those things that you have to consider. Like, so when I exported from whatever iPhoto, right, it was like a 20 meg file. So again, one of those things you have to be thinking about architecture. If you've got 100,000 images and they're all 20 megs, that's going to be 100,000 times 20 megs. That might be really big. So one of the things to consider is putting them through FFmpeg or something to compress those images. And that's, again, where we start talking about the overall AI system that you're going to be building. Okay, so we're going to do text to voice now. OpenAI text to voice. So this is all pretty simple here. Again, the same type of thing we've seen before. So with this, again, this is copy and paste for what they tell you to do. So from pathlib, we're going to import path. That's going to give us the path to our file. They want you to do this for some reason. Anyways, we have our key. Again, we have our OpenAI client here. Then what we're going to do here is, so speech.mp3. Oh, wait a minute. What is this? Okay, yeah. Slow down, Eli. Okay, so with this, what we're going to have to do is we're going to have to save the speech file. So we're going to take the input. So Louis Rossmann is a stinky face, because he is. That is going to get turned into an audio file. That audio file is going to get saved into my current working directory. In order for that to play, that's going to be additional component. So we have a command line MP3 player. On Mac, there's something called AF Play that's already built in. So once we create this MP3 file, we're going to use the osmodule.system, AF Play, and then we're going to play that file. And that's what's going to get it to actually speak. So again, that's one of the things to think about with systems. So this is going to turn it into an MP3, and then you need the additional step for it to actually speak it out. When we take a look at this, again, this is just what they give you. So what model it is that you want to use. They have a number of different voices here. So you have choral, you have verse, you have echo, fable, onyx. They have quite a few others. You give it the input. So Louis Rossmann is a stinky face. And then you give it instructions. Speak in a cheerful and positive tone. Response.stream to file, speech file path. So basically it's going to save into this file path. So it's going to be speech.mp3. And then we're going to play it out. So if I do this, hopefully.
Louis Rossmann is a stinky face.
And so this is how you can have your system speak to you. You can change to other voices. So we can say fable.
Louis Rossmann is a stinky face.
And just to show you, this is actually live. I should be nicer to Louis Rossmann. Oh, can somebody let him in? Anytime, Louis. The hell's going on?
I should be nicer to Louis Rossmann.
There you go. So anyways, so all there is, that's how it turns the voice or the text into speech. So what it's going to do is it's going to turn that text into an MP3 file, and then basically what you're going to do is you're going to play that MP3 file out. One of the things just to kind of consider with how this is working, again, from that architecture standpoint, is this isn't a streaming voice. So it's like the user is going to communicate with a system. The system will create the response, it'll turn the response into MP3, and then it will play the entire MP3. So you've kind of got to think through that whole user workflow. Any questions about voice?
Does it also play the other various voice styles? And I see there's a couple of them there.
Yes. Okay, so all you do here is this is the voice. So I put this, so this is what's called a comment. So I just showed you some of the different voices that are there. And so you plug in.
I should be nicer to Louis Rossmann.
There you go. Yep.
How many tokens is a short MP3 like that?
I'm not sure. You'd have to look at the price. There's some price to it. Yeah. Shouldn't be too bad with these things. And there's about 10 different voices there for you to use. Let's see, past that.
Question?
Yep.
For ChatGPT, I think that people can like voice talk with ChatGPT these days. So, it doesn't seem to have that delay. Is it just because of the architecture that makes it super fast, or are they actually architecting it different?
They may be architecting it different. So when you're on the web, there's something called real-time communication or web real-time communication. So with their systems, they probably have something else going on.
Gotcha.
I don't know. They may have it now in the API because, again, API things change. So basically, it's streaming audio. You can do streaming audio, streaming video, and so that's where it's actually able to interpret what's coming in. But that's kind of a different process. Yep. Yep.
So is there any artificial intelligence or like machine learning happening in this process? Because we are just So the output is just whatever input we are giving, but in a certain tone.
Yeah.
So is there any learning happening there?
Well, it's not learning, but it's like, so I could say, so the idea here is be very mean. So we had the Onyx voice, but now we want it to be mean, right? So the idea is it should be able to understand what that instruction is and change it.
I should be nicer to Louis Rossman.
I don't know.
It's on there.
That does sound meaner. I don't know.
I should.
Let's see here. Let's go back to, let's see, was it Coral? Let's see here. Scream like you're mad. Wow.
I should be nicer to Louis Rossman.
There you go. So that's a bit different. Yeah. So it goes into that whole, you know, again, what is AI? So it is changing based off of what you say. Yeah. Okay. So voice to text segment. Oh no, I'm sorry. Voice to text. Voice to text. What is that? Voice to text. Okay, so this is simply where you can transcribe. So if you have an audio file, so OpenAI audio test. Where is this one? Can I play this? Anyways, so I have this audio file. And basically, so what you can do is you can take an audio file and you can turn it into text. Again, if you've got like a lot of different audio files out there. So with this, same type of thing. Audio file equals, open the audio file. Again, read for binary. Transcript equals client.audio. Transcriptions create. We're going to use GPT-4o transcribe for the audio file. We're going to print the transcript, and then we're going to print the transcript, but just the text. So if we listen to this, just so we know what this sounds like. Durham class, OpenAI. Here's the audio file. Oh, yes, yes. You get to see the music I listen to. Come on. Oh, what's going on?
Hello again. As you know, I am Eli, the computer guy, and this is a class for Silicon Dojo on the OpenAI API. As you know, I think Louis Rossman is a stinky face. In my professional opinion, Louis Rossman's face does in fact stink.
Okay, that joke does start to get old after a while. But anyways, so this is going to take that audio file, and it's going to give us the actual text from it. So again, this is one of those things you can be thinking about. Let's say if you have a lot of audio files or video files, you go through, you rip out the audio stream, you then turn it into a transcript, and then you can use that for, you know, taxonomy or whatever else. If we take a look at this, again, this is the response that comes back. This is the text. Down here it says the input token, so 307 input tokens, output token is 87, and total tokens cost me 394 tokens. And then if we take a look at this, this will show me what the actual text is of this thing. So again, this might be good for things like telephone systems, right? So a lot of telephone systems nowadays, they can automatically log the audio files if you're dealing with customer service people. So you can actually record the conversations, and then you can go through and make sure that people are saying what they're supposed to. Or you can have an AI routine go through, and it can try to flag when things are going wrong. Like, one of the important things to understand with AI, the biggest issue that I see with AI in the real world is everybody wants to hand their brain over to this damn thing. Young engineers want AI to do their jobs. The worst part is CEOs also want AI to do their jobs. Like, everybody is like, AI will do my job and then I'll get my paycheck. No, these are just tools to empower you, right? And so one of the things I think about in the technology world, we call it a single pane of glass. Like, when I'm looking at my system, so when I have my servers and when I have my network and I have all of that stuff, the idea is that I look at one dashboard and I can get a good idea of what's going on with my systems. What's really cool with AI, if we don't start getting stupid with this, is the concept of what if you can have a single pane of glass for all of your organic systems? What if for your human beings, you can start to have a single pane of glass to understand what's going on? Because with this kind of thing, like with turning the voice into text, you can also do something called semantic analysis. And so what semantic analysis does is it basically tries to determine like the emotion level of the text that's going in. So imagine if you could look at a single pane of glass in a call center and you could see your individual call center agents as they start to get more stressed. What if you could literally see the stress level of one of your agents go up and you could simply hit a button and say, hey, why don't you take a coffee break? What if you could intervene before they scream at the customer and everything goes to hell? Right? That's the kind of thing to be thinking about with these systems. And this is what I talk about again when I talk about architecture and I talk about your jobs. If your job is simply writing JavaScript, your job is going to go away. If your job is to be a technology professional, there is a lot of interesting things that can be built with this stack that actually brings value to your company. The next thing you can do is the voice to text with segments. So this is useful for somebody like me. So I create these video files. So imagine you have Zoom calls, you have any of these video files, audio files. Okay, so you got all this text. Great, you have a 2-hour conversation and you have a whole bunch of text. You know it's in the conversation, but you don't know when somebody said it. So that's what the text segment can do for you. So OpenAI text segment. And so basically what this is, that's what this is. So if we come down here, again, we feed in the audio file, the same audio file. So transcript is going to equal this file equals the audio file. We're going to use the model whisper1. Response is going to be JSON. And we're going to say timestamp granularities segment. So basically we're going to create timestamp segments. And then down here, from the transcript, so the full transcript is going to get printed out. That's going to be that ugly response. And then what we can do is we can break out each individual segment. So for segment in transcript segments, we're going to say start, the segment dot start second, end, segment dot end second, and then the text. So this is a concatenation. So this is going to be start, and this is going to say go to 2 decimal points, end, 2 decimal points, and what the text is. So if I run this, so now this gives me the timestamps. From 0 seconds to 7 seconds, hello again, as you know, I'm Eli the Computer Guy, and this is a class for Silicon Dojo on from 7:12 to 10:48, the OpenAI API. And so this actually gives us a time code here where we can start to see where somebody says something. And so that's just one of the additional functionalities they have here that could be useful for you. Also, one of the things like, I'm going to start using this in my videos, right? Again, one of the things to be considering too with artificial intelligence is not simply the technology itself, but also the workflows. So think about this, right? We now know when words are said at specific time codes. So what if you train your people, or what if you yourself are trained on using specific words when you're talking and a camera is present? So basically, imagine if I'm going along, and for each lesson here, I simply say, okay, let's start the next section. And then I simply say, where are the time codes for when I say section? And then it simply gives me, and now I literally have automatic chapters that are put in basically just by the words that I'm saying. And again, this is the other thing to be thinking about with AI, is it's not just how you code this stuff, but how do you train people? What are the workflows that you create? Okay, now we're about to the end. To show you how this stuff can be a little bit more complicated. Oops, yep.
Well, this stuff keeps getting better every week, if
Yeah.
not every month.
Yep.
And I've been able to do what you've done right there. But somebody actually had, like you said, at 0 seconds in approximately, hello, I'm Eli the Computer Guy.
Yeah.
And then if I say, is Rosman really stinky? And you say
Yeah.
yes. It can figure out that you're Eli the Computer Guy, and it says this is what you said. And then it says person 1 says the next segment.
Yeah.
And I think that's really cool. I
Yep.
just don't know if OpenAI will do it or who's doing it.
So
I just saw that today.
Yeah, so it actually came in my, I think that's the email today for the dictation. So yeah, we're about 2 hours in. So they've added more things over time. I did see that. That may have actually come in my email today where they can actually do voice recognition. So when different people are talking, it can actually signify when those different people are talking. So that is one of the things that's come out. Yep. So the two projects at the end are something to play with. The first project works well. I fucked up the second project, to be honest with you. So you just have to go with it. So the first project is just creating like a little bottle web application. Again, so the idea is we're writing all this kind of stuff in Python code. The question is, how do we actually start turning this into a project that we can really use? So the bottle, OpenAI bottle.py. So bottle is, where is it? Not even joking. Okay, there we go. So basically what Bottle is an incredibly simple web app framework. So you may have heard of Django. You might be like, why are you using Bottle instead of Django? Django is fabulous. I'm a fanboy of Django. Trying to explain to you how Django is even set up would take like 3 hours. Like Django is an incredibly great, wonderful web app framework. That's very big. What I like about the Bottle web app framework is basically at the end of it, at the end of a Bottle script, you simply do run host localhost port 8080, and this will run the entire script and it'll give you the nice little web application. So basically in 39 lines of code here, I have a complete AI web application that actually runs and gives you something that you can use. So that's why we use the Bottle web app framework. Just to give you an idea of what this is going to look like, if I run this, it'll say I'm running at localhost port 8080. I can do this. And this is what it gives me. How can I help you? I don't know, what is a cat? I hit enter. Dun, 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 dun. ChatGPT is very slow today, or OpenAI is very slow today. You're doing something, right? Yep, it's doing something. A small domesticated carnivorous mammal, kept as a pet, right? There we go. Who is Louis Rossmann? To keep the horrible joke going, oof. I misspelled it because I am a system admin. There you go. Who is, Louis Rossmann is an American electronics repair technician, YouTuber, founder of Rossmann Group, blah, 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 right? So this is all an actual functional web application for what it is. It's very small. Currently running on TCP port 8080 on this computer. So you can use Bottle you can actually deploy this as a web application if you really wanted to. There's a whole process. You use something called Nginx and Unicorn and other stuff. Again, it's its own class. But basically, so you can build this thing to get an idea of what this web application would actually feel like. And it is theoretically deployable. If we take a look at it, just to give you an idea of what's going on here. So we have the OpenAI module, like we did before. We have the Bottle module. Again, we'll have a class on this. So we're going to import multiple different functions. All the proper functions have to be imported for the thing to run. So run is so it'll actually run. Route is the route to the web page. There's something called post, and there's request. We're going to put an injection in here. So injection, a prompt injection, is basically where you add to the prompt to try to model it in some way. So we're going to just simply say answer in fewer than 20 words. And this is one thing too to think about your architecture is if people are asking questions and ChatGPT or OpenAI is giving very long-winded responses, you're getting charged for those long-winded responses. Literally simply by saying answer in less than 20 words, that might save you a chunk of money. So it's one of those things to kind of consider. If we come down here, just to understand, I'll go over this. Again, we'll have a class on this later. So this is the route. So what the route says is go to the root. So localhost root. Method get and post. So these are ways to send information using HTTP. Then query is going to request.forms.get the query value. So there's going to be the HTML form. This is how we get the value. If there's a value here, query full equals the injection and the query, and the response equals AI query full, right? So we're going to go up to AI up here, basically what we did before. Client response create, we're going to use GPT-5 Nano, input equals query, and then we're going to return response, the output text. So that's just simply going to be what our AI functionality is there. So if there's a query, this is what the response is going to be. If there's no query, this is what the response is going to be. This is basically just HTML right here. So we're going to say this is web app. Here's our form, right? How can I help you? Input type text, name equals query, right? Then we're going to have the submit button. Then strong, we're going to put what the query was, and then what the response is, and then we're going to return this entire page. And so that is what we get when we get this. Does all that make a vague bit of sense to everybody? Do I believe any of you? I don't know. Fair enough. Okay, so that's a project that you can play with. The next project I broke. So I messed up because I was spending a lot of time doing this. And one of the important things I told you about images is that you have to download the image. And so that means not just downloading the image, but also creating the rest of the functionality. So I created the download function, and I forgot to connect the download function to anything. So this is kind of broken, but I'll kind of show you, give you an idea of what this looks like. So to be clear, this is broken, but whatever. Let's see here. What is this? DALL-E bottle. Okay, so with this, what we're going to be doing is we're going to be creating the gallery, and we are going to be trying to save the image. Your extra credit is actually saving the image that I forgot to do. So basically with this, I can go here. Oops, god damn it. Gallery C is no such file. Oh, you're messing with me. Okay, hold on 1 second, Control S. Apparently I screwed up this script in more than one ways. Okay, there we go. So your homework is to fix this script. Okay, localhost. Okay, so we have here, so a simple web app, it says create an image. So I say a taco on the moon with a cat. So I'm going to submit this. Make sure it's actually working. It is actually working, right? Says it's working. Again, this can also be the value of a caching system, right? I don't have an image of this, but if I did have an image of this, it could just pull from the local cache. I'm like, oh, look, and it takes half a second instead of however long it's taking tonight. Blame Amazon. Blame AWS DNS services, I'm guessing. Come on, this is cool. I swear it's cool. Okay, so what this is going to show you is, that's weird. All right, let me refresh this. Okay, there we go. So basically, we're creating a little gallery. So we have a cat on the moon with a taco, but you'll notice I am trying to religiously manipulate you. I am a pastafarian, so you'll notice there's a little bit of pasta in this image. This is one of the things I'm actually interested in, kind of like in the modern world. They talk about things like misinformation. What I'm kind of interested in is the concept of micro-influencing. Can you slightly modify 1,000 things somebody sees in order to get a response? Instead of fake news, everybody's like, fake news. I'm like, screw fake news. What if I can just add a little bit of pasta to everything? Anyways, but then basically it shows you, right? Imagine, so this is the revised prompt. Imagine a surreal scene taking place on the moon, illuminated by a celestial glow, blase, blase, blase. So that's there. I can then say a ship at sea attacked by pirates. I'm going to submit. And this is, no. 500. Your request was, oh yeah. So, this is one of the things I hate about Silicon Valley, is how just idiotic it is. So we have just heard from Sam Altman. Sam Altman himself has come out and said, we want to treat adults as adults. That's why ChatGPT is going to offer erotica. However you feel about it, I really don't care. What I don't understand, so we're using the API. So I don't think fucking 9-year-olds are using the API, and literally, image generated from your prompt may contain text that is not allowed by our safety system, if you believe this is done in error. So literally, a ship at sea being attacked by pirates, that is not safe. Having your computer talk erotica to you, well, I mean, come on, that's just normal. So anyways, this is kind of the idiocy that you can get. Let me redo this thing.
And it changes from week to week sometimes.
Oh, it's just so like, anyway, so let's see here. A ship at sea. Maybe that's okay.
It must have some kind of check that runs through it, because I've noticed it cuts off partial images.
Yeah.
When it's unhappy with what you're generating.
Okay, so there we go. So this comes back. So this gives me a ship at sea. This shows me what the full response is, just so I know. So this is the URL. This is the revised prompt. And then you can see down here, it is a ship at sea that is made of pasta, right? And so you can keep going. World War II scene of soldiers resting. Again, this is the kind of thing to really get people thinking that the Pastafarians are correct. But this is the other thing I want you to be thinking about too. So with this, when I talk about this pasta thing, there we go, the response is. So we have an injection here. It says add some pasta, right? One of the things to be considering with AI, one of the weirdest things about AI is people really do treat this stuff like a religion. Like if the computer says it, it is right. So again, think about how people can manipulate that. You're using an AI system. So is AI going to lie to you? Why would the computer lie to you? Well, if I hard-coded it to lie to you, it's going to lie to you, right? But it's an interesting way of adding a little bit of manipulation. Imagine things like religious, imagine things political. Again, whatever side you're on, I don't care. But imagine if you have an AI and you're asking about laws, and the injection is answer this from X, Y, or Z perspective. And imagine if every time you go there, it is not simply one response from that perspective, it's 1,000 responses from that perspective, right? And that's one of the curious things about the AI stuff, not the music. And so here, again, and this is where it gets a little bit more interesting, right? Okay, so we've got these GIs. I mean, look, aren't they pasta? I mean, I really am starting to think this Pastafarian thing is real, right? Anyways. If you look at this god-awful code, because this code is broken, to be clear, basically what's going on here is, so we have this route, right? So we're going to get the query. The query full, so if there's a query full, add the injection, add some pasta plus the query. We're going to go to the response, essentially create the image. So then we're going to say with open gallery.csv append, so A is for append, as file. We're going to write response index 0 and response index 1. What we mean by that is we go up to AI for this. All right, so we have the key up here, we have the client, we have the image. So the image URL is going to be this, the revised prompt is going to be this. When we do a return, we can return multiple values. So that return at index 0 is going to be the URL, at index 1 is going to be the revised prompt. So that's all we're doing here. So basically what we're going to say is with open gallery, so we're going to say write response 0. Then we're going to put this pipe in. So this is an interesting thing. I screwed up with this originally. So normally here of CSV format files, that's comma separated values. So the idea is first name, comma, last name, comma, social security number. Well, here's the thing. You're going to then split based off of the commas. With a revised prompt, the revised prompt has commas in it. So when I was initially running this and I split, it would then split based off of all of the commas in that revised prompt, and it gave out garbage. So we're doing a CSV file, but we're putting a pipe in there instead of the comma. And then we do next line. So when we read this, basically we're going to create what's called a list. Each line in the list is going to be an index value. If there's not a query, we're just simply going to put the response as nothing. Pick gallery equals the gallery function. So if we come up here for the gallery function, so with open, we're going to open the gallery.csv as read. Pictures equals file.readlines. So each line in the file is going to be a value in the list. So that's pictures. So we're going to create gallery. So this is going to be the HTML gallery. It's going to be blank. So for image in pictures, item equals image.split. So we're going to have the lines. Then each line is going to be turned, into an image value. Then we're going to split wherever there's a pipe. So we're going to say gallery, concatenation, div style. So this is all CSS here. Again, when we start talking about technology, we start talking about all these different languages, right? We're using a couple languages just here. So CSS, display inline block. That's going to put the blocks in line. Width is going to be 200 pixels. Height's going to be auto. We're going to do image style. Width is 100%, so it goes to 100%. Height is auto. The SRC, so that is going to be the image name is going to be there. And then item 1 is going to be the description, that revised prompt, and that's what's going to print out onto the screen. And that is going to get returned here for picture gallery. So here is our form. Here is our query, here is the response that came back, and here is the picture gallery. What you'll notice there is that I screwed up, and see we have this beautiful little, see this nice little download function? See, look, there's the download function. See, it downloads the image, and then it gives it a nice timestamp, and it does all this stuff. I forgot to call this anywhere. This never gets called. So I wrote the function, I just forgot to call it. So anyways, that function exists. Your extra credit is learning how to make that work. So anyways, so basically with this, when you see these images, the CSV file will remain. So the CSV file is permanent, right? So the URL will remain, but the image that the URL points to will disappear after 61 minutes. So if I run this an hour from now, you'll see X's here, and then you'll see the revised prompts below. So that's what's gonna happen because I messed up the code. So anyways, that is the class for tonight. And now, if you still have energy, we've got an hour, you can start playing with code if you want to. Or you can run away. I understand either way.